Hello, I'm Adrian Jennings, Chief Product Officer at Cognosos, and in the next 30 minutes or so I'm going to be talking to you about managing automotive inventory fluctuations in periods of supply chain disruption. And we're going to talk about supply chain visibility, which is nothing particularly new, but in particular we're going to focus on the assembly plant itself and its surrounding facilities and why that visibility kind of goes dark in that last mile of the supply chain. And so we'll review why that is, why legacy solutions haven't really provided the answer, and I'm going to introduce you to a new generation of asset management solutions that can shed the light on that part of the supply chain that we don't see today. And this is the time to talk about supply chain, right? Because what a mess we find ourselves in. In passenger vehicle, IHS reported that we were already 20% down on vehicle manufacturing from last year just by closing plants temporarily. And now we face the material shortages brought on by last year. 670 odd K fewer vehicles produced in the first quarter this year just because of semiconductors alone. Let alone all the other material shortages that we're seeing in terms of resins and nylons and fibers and plastics, and that's likely to go on for many months. And then there was this, right? The Suez Canal blocked, fire in a Renesas plant in Japan, the drought in Taiwan when one of the primary resources you need to build silicon chips is water, and who knows how many container ships anchored offshore in California right now waiting to unload. So it's a really unprecedented global situation. And there are various ways that manufacturers have responded to this. On the left, one strategy is simply to continue building product, keep the plants running, and build a large work in progress inventory of vehicles that are unfinished, waiting on those parts to get delivered and finished and then shipped. So that's one end of the spectrum. On the right hand side, the other extreme is just halt all production because you simply can't get the parts. And then many people have taken the middle road, which is, look, the supply chain is not closed off, it's just running slowly at reduced capacity, and therefore target the parts you can get at the most profitable segments and the most profitable vehicles. And it doesn't matter which of these strategies is being executed. The bottom line is production is down right now and the productivity must be recovered. The tragedy right now is that production is down right at the time where the economy is picking back up, consumer confidence is back up, consumer spending is back up, people are looking to purchase. And that's right at the time when we find it hard to deliver. So supply chain issues have caused the situation, but as we ramp up to catch up, then that's really going to exacerbate things and make it even worse. So I said we were going to talk about the assembly plant itself and the supply chain around this assembly plant, and that's both on the incoming side and the outgoing side. Parts on one side and finished goods on the other. And an assembly plant and manufacturing as a whole is a massively complex feat of motion. The entire manufacturing supply chain consists of taking raw materials and moving those through the supply base to be built up into components and sub-assemblies, moving all that to the assembly line, where on site there's a very specific and high cadence process of moving parts to the right workstation at the right time in the right sequence, making the joins onto the product as they flow through the assembly process, and then on the outgoing side through test, inspection, and marshalling for shipping and actually shipping out through the supply chain to the end user. And so manufacture is a complex feat of motion, and in the assembly plant itself, there's a couple of different categories of motion. On the top line, constrained motion, and on the bottom, unconstrained. And what I mean by constrained motion is that motion that's mostly it's the assembly line and in high volume parts of inspection and test as well, where the motion of the thing you care about, in this case the product, is constrained and can't really deviate. You know, on a moving assembly line, unless something really bad goes wrong, the product moves at a steady pace in a straight line. And even in a pulse line, in a lower volume plant, nevertheless, the trajectory is very much physically constrained. And not that much can go wrong there. The unconstrained motion are those parts of the plant where things move freely. Those things being trucks bringing semi-trailers in with parts. It might be distribution of those parts within the plant. It might be the flow of vehicles as they go through any kind of repair and rework and out through the shipping and distribution channel. It's unconstrained, meaning things can move anywhere, and primarily those parts are the manual parts of the process where people are moving things around, and as with any manual process, things can go amiss, the mistakes can be made, and this is where we see a lot of the inefficiencies on the campus. And so when we talk about those things on the left, inbound parts, the process of getting parts from the gate to the dock door, we refer to as yard management. The process from the dock door to line side is intralogistics, the industry formerly known as materials management. That process of managing off the assembly line the flow of work in progress through test, inspection, repair, rework, upfitting and options, that is WIP management. And finally, on the outbound side, the process of marshalling vehicles for loading either at a railhead or if it's onto trucks or however they're being transported, finished vehicle logistics. And in finished vehicle logistics, we're not just talking about those parts of the process that happen on the assembly campus itself, but also those off-site distribution centers, vehicle processing centers, those parts of the supply chain with huge yards of movement and motion and marshalling. So when issues arise, when productions ramp up, they arise in different ways depending on the type of motion. In the assembly process, when you start to ramp up production, you tend to see quality issues. You can't normally just run an assembly line faster. You know, turning down the takt time makes a lot of things break. The way you ramp up production is by adding shifts and adding overtime. And when you do that, normally you're bringing in less experienced staff, and that leads to quality issues. And that actually feeds the unconstrained part of the process as well, because now you're feeding more vehicles with quality issues on a ship hold into that rework process. Along the bottom though, the way that unconstrained parts of the motion fail tends to be with throughput. The assembly line, you maintain the throughput, albeit you build lower quality product. In these unconstrained parts of the plant, your throughput can choke actually as you try to jam more trailers through the yard, as you try to jam more vehicles through repair and rework, as you try to manage larger inventories of product for shipping. Those processes become congested, throughput drops, and actually those processes can break in a rather exponential way. They work when they work, and when they go wrong, things can get pretty bad pretty quickly. So let's talk a little bit about why that's the case. In the perfect world, when you're managing a fleet of assets, and here I'm focusing on outdoor yards. So, you know, any manufacturing facility has an inbound yard, as I said, the trailers bringing parts to the plant. And in vehicle manufacturing, somewhat uniquely, we also have kind of WIP and outbound yards. The product we build, they're big, and they have their own wheels, and they can be moved around easily. So any place they need to be staged and stored and buffered, that tends to be done outdoors because you need the space and because you can. You know, they're weatherproof and they're easy to move around. So the supply chain on a vehicle assembly campus tends to be a great part about yard management, or yards of different kinds. And in the perfect world here, starting at the top, you have a yard with a known capacity. You would have perfect knowledge of where everything is out there and where the spaces are. And as a vehicle, be that a trailer or a tractor or a car or a front end loader, needs to be parked out there, you know where to tell the driver to take it. And the driver does that. He puts it right where you tell him to. And that means your yard status over on the left there is exactly as you intended it to be. And there's a virtuous cycle now. You're going around that loop, and you have full knowledge of where everything is, everything's parked perfectly, and life is good. And when that happens, when you come to pull vehicles from the yard, which you always have to do to feed the downstream process, then you can instantly go to the place where the vehicle or the type or the class or the status of vehicle is that you need to feed the process. You go right to it, you pick it up, and you efficiently feed that downstream process, whether you're sending a switcher out into the trailer yard to pick up a trailer and feed the dock door unloading process, or sending a driver out in a golf cart to find a tractor parked out on the back 40 that needs to come in for repair to feed the repair process, or you're sending a minibus full of drivers out to the marshalling yard to pick up certain vehicles to get staged for shipping. You're feeding those downstream processes efficiently and keeping everything moving. So the reality is a little bit different. I mean, that doesn't really happen anywhere. What happens is that you have a mostly known yard capacity, and you plan vehicle parking the best you can, and drivers do the best they can, and the yard stays close to the intended status, and the cycle goes around. And it's not perfect, but it reaches a steady state. And you know what happens here are silly small things happen where your status is that you think that I've got nothing parked in row B. Let's put the next batch of vehicles in row B. Tell the driver. Well, the driver gets to row B, and actually there's vehicles there, so he drops it in row C. That was easiest. And now the yard status isn't quite what you thought it was, because now there's stuff in row C that you weren't expecting, and so you thought there was capacity in C, which there isn't now, and it goes around and around and around. And as I said, it's not terrible. It reaches a steady state, but it does mean that there are delays in the pickup of vehicles. Nothing's quite where you thought it was. There's search time and there's delay, and now the downstream processes are inefficient. And there's another feedback loop in here as well, which is that as people are heading out into the yard to clear vehicles, let's say you went and pick a batch of 10 for staging for shipping, that affects your yard capacity. But if they didn't quite get them in time, that capacity is not available quite in time, and now suddenly it feeds back into the loop, and that's what can make things break quickly. And down state is it kind of goes to pieces, and it goes to pieces pretty quickly. You really don't know the yard capacity. There's no attempt at planning or no ability to plan. So the vehicles are parked haphazardly, the yard status is chaotic. And what that means when you come to pick up and feed the downstream processes is that the vehicle pickup is interrupted. And that starves those downstream processes. And we've probably all seen this. Let's think of the repair example as a good one, where maybe you had a much more modest supply chain issue than we're facing now. Maybe a run of parts that you couldn't get, or a run of quality issues, and that all happens really fast. And suddenly it's like, okay, just go find somewhere to put it, and stuff gets scattered everywhere outside. When you come to pick them up, now you're actually creating a big issue of just figuring out where things are. And let's say you were heading out to pick up a trailer, and it takes you 15-20 minutes to go find the right one. During that time, that dock door is sitting empty, and the dock door utilization drops, or a repair bay is sitting empty, or a train is sitting at the railhead longer than it should be, waiting to get loaded. But what happens is the utilization of the downstream processes drops, and that's where it hits you in the pocket. That's where your throughput starts to drop. It's not so much that the throughput of the yard management drops, it does, but when you can't feed the downstream processes, then the utilization of those assets downstream drops and the throughput tanks. And so those starved downstream processes mean that sometimes you don't even meet your catch-up rate. On the left here, we're starting from a low production rate as we're at now. We're not really shooting for normal. A lot of people are shooting for a catch-up rate where we can kind of backfill the lost production and meet demand. Well, the problem is when you try to run those processes faster than they're designed to go, they kind of choke. And when they choke, you may not even make it back to normal. You may be shooting for 110% and not even meet 90%. And that's not uncommon. And that's what I mean by these processes failing exponentially badly. And the only way to make up that gap is to add even more shifts and even more overtime. And that's where it hits you in the cash. Right? That's a lot more people and plant time to pay for to make up for the fact that you can't just push things through these yards and this supply chain as you should be able to. So where's the remedy? Well, the first step of the remedy is right here. If you could, even in a situation where things are going nuts, when you're shoving vehicles or trailers in every corner that you have, and it happens, if you could know the yard status, get rid of that chaotic yard status, if you could know the location of everything out there, then you decouple the management of the yard from the feeding of the downstream process. Even if your yard management is chaotic, if you have known state, known position of everything, you can efficiently go fetch exactly what you need when you need it and keep the downstream processes running. Now, obviously the solution is to manage the yard process, to always have known capacity, to always have planned parking, to always have things put exactly where they were supposed to be. And that follows. Step one is creating the visibility to decouple. So taming the chaos, some of you have maybe read some of Peter Drucker's work on management. And I think it was his first book back in the 50s where he gave us the notion that if you can't measure a thing, then you can't improve it. And you certainly can't measure something if you can't even see it. So when we talk about visibility, we talk about asset visibility, real-time asset visibility, which is kind of what I was alluding to on the last slide. What you're getting there is real-time process feedback. It's not a question of really where's my stuff, but how's my process doing? And how is my ability to feed the next process doing? And to improve that, to optimize that, you need to be able to measure how you're doing. And to be able to measure how you're doing, you need that visibility. So that's what loops us back here to supply chain visibility. And supply chain visibility is nothing new. It's something we've talked about for a long time. It's something that we've invested a great deal in. But there's an oddity here, which is kind of what we tend to refer to as the last mile. That last piece of supply chain, think of the part of the supply chain that's in the fence, inside the fence. Trailers to dock doors to line side, products to rail heads and truck loading areas. We have almost no visibility in general in manufacturing into those parts of the process. We have all kinds of visibility on the assembly line, all kinds of visibility back through the supply base, and almost none right at the crucial point where you absolutely need to see. It's like bringing a boat into dock and suddenly becoming blind 100 yards from the jetty, and somehow you have to not smack into that thing. So, that visibility of the last mile is critical. It's the most critical part of the process because it's the piece that feeds the just-in-time, just-in-sequence, high cadence of the process inside the plant. So why is, tend to call this yard blindness, why is that an accepted problem? Why aren't there solutions to this? Well, there are, actually. There are asset visibility solutions, real-time asset tracking solutions out there. And they've been around for a long time. They've been around for a decade or more. and in some industries they're being adopted much more widely. Healthcare, for example, hospitals are well ahead on tracking and monitoring the flow of their critical assets in a healthcare environment. So why not here in manufacturing? Well, the technologies that are out there, they're getting a little long in the tooth. They've been around. The turn of the millennium technologies that the pioneers developed, right? These were the first real-time asset tracking solutions to come to market. The focus was very much on performance and creating business value, and they did that. They absolutely achieved that. There's very high fidelity tracking available. There's proven business value in getting this visibility and optimizing the yard management process. But those first generation technologies also brought with them some baggage. They can be very difficult to implement and very costly to implement. Or they're very straightforward to implement, but the technology is ineffective. And what that leads to is a lack of recognized return on investment. These legacy solutions brought with them all of the value, but way too much cost. And that is the reason that we still suffer from yard blindness. So, shouldn't be a surprise to you that the reason I'm presenting to you right now is that Cognosos is at the forefront of a new generation of real-time location systems. We tend to call it RTLS 2.0. And the focus of this new generation is to say, let us learn the lessons from the pioneers. Let's take those technologies, but let's apply newly available technologies and tools and focus expressly on reducing the cost. And if we can maintain the performance of the first generation systems and in the second generation reduce the cost significantly, then the return on investment is perfectly viable, and then adoption takes off, as it currently is. So let's review just quickly what it is about those first generation solutions that makes them complex and costly to deploy. And I should take a quick aside here to mention that we have produced a white paper that goes into this in much more detail. And either look out for an email from us or have a look on the website. You should find it easily. Do recommend you read that because it explains a little bit what the difference between old generation and new generation real-time location solutions is, and should give you some insights on how to evaluate and purchase the solutions. So what we're looking at here is a top-down view of a plant and with a measles outbreak. And what I'm showing here is each red dot being a piece of fixed infrastructure that is required for a typical legacy tracking system. And the way tracking systems work is the item that you want to locate, the trailer, the car, the tractor, the excavator, the train car, whatever it is, would have a tag on it. And that tag is in communication with some kind of infrastructure. And it's that infrastructure, fixed infrastructure, which helps us calculate the tag location, whether that be through triangulation or some other form. That's how tracking systems work. And it's true to say that if I'm a tag sitting in the middle here, the best possible performance is if I'm surrounded by these infrastructure devices. Here they are all around me. So they tend to be deployed in a network, and they tend to have, in the old generation, fairly short range, which means you need a lot of them. And imagine now rolling out this solution in a plant. Every red dot requires a device, which needs to be purchased, and buying a lot of those becomes expensive. But more expensive still becomes, how do you run power and communications out to these guys out in the yard? Maybe you have light poles, maybe you don't. Maybe the light poles are in the right place. Maybe the light poles have power 24/7, or maybe they don't. Maybe the light poles have power 24/7, or maybe they don't. Maybe the light poles have power 24/7, or maybe they don't. Maybe the light poles have power 24/7, or maybe they don't. Maybe the light poles have power 24/7, or maybe they don't. Maybe the light poles have power 24/7, or maybe they don't. So actually provisioning these devices with power and networking can become extremely costly, to the point where I've seen people, out with directional drilling rigs drilling under concrete to run new cabling out to new poles that they've erected in order to get this kind of coverage around a site where they want to track. So that becomes very costly, it's very time consuming, it's very disruptive to the operation, and it's an example of the kind of baggage that I said that these pioneering systems brought with them when they focused really primarily on performance and not so much on cost, or total cost of ownership, I should say. So there's a second kind of legacy solution, and that is one that leverages GPS. And the thing about GPS is the satellites are the red dots, effectively. And we already paid for the satellites with our tax dollars, so you can kind of use it for free. But you still have to communicate with the tags. You still have to ask the tags where they are. And that requires, what I've shown here is yellow dots of overlay communications infrastructure. Whether that's Wi-Fi or some proprietary communication system, nevertheless, it still requires hardware to be deployed, to be powered, to be connected up with communication backbone. And it's cheaper and it's less complicated than the red dots, but nevertheless, it can become prohibitively expensive and disruptive. So the new generation of solution has focused very much on how do you minimize the infrastructure. And the key thing here, and we talk about this in the white paper in more detail, the key thing here is companies like Cognosos, only a few years old, came into this business with new tools at our disposal. We were able to leverage the cloud and artificial intelligence and machine learning as fundamental tools to make the system cheaper in the way that the pioneers never could and still haven't. And the AI and the cloud are very nebulous terms lots of times that have not a lot of meaning or value necessarily attached to them. But in this case, there's a very specific way in which they're being leveraged. What we're showing here is a single device attached to the building, easily powered and networked to cover the entire site. And in the case of Cognosos, that's a very low-cost device with a range of 2 miles. And it means that that device can hear a GPS tag anywhere in that 2-mile range, whatever it's attached to. So it's clear why that is very straightforward to deploy, very quick to deploy, very low cost. It's just a single device. And the device itself is very low cost because in that device is a very cheap little radio, the kind that is in the remote control for your car key fob. And your car key fob has a range of a few tens of feet, maybe. But it only has a very little amount of processing power. It's the processing power you can fit in that little box and power off that little battery. And this is where the cloud and AI comes in. If you take that radio and do all the signal processing back in the cloud, you can throw a brain as big as you like at it. You can fit a much bigger brain in an Amazon data center than you can fit in the key fob for your car. You can also throw a huge amount of signal processing at it and use advanced algorithms back there that you couldn't possibly do in that key fob. And that is what allows you to communicate for a couple of miles with that little radio that's in your key fob for your car. And that's what I'm talking about in terms of a new generation of technologies coming in the post-cloud, post-AI era, leveraging those things in order to create the cost reduction that we need to make these yard management solutions viable. So now we can think of the 3 different yard operations that I alluded to already together. That single device in the middle can now cover the yard operations out in the inbound logistics side. The trailers coming in from the gate to the dock door. Track every single one of those trailers in real time, know where they are, know when they arrive, know whether they were parked in the right place, know whether they were taken to the right dock door, know whether the dock door unloading is happening as fast as it needs to be. And all of those things help you minimize congestion, optimize dock door utilization, real-time alerts when bottlenecks occur and replanning is required, and things like minimizing detention charges by hanging onto empty trailers when they should have been cleared out of the yard days ago. So that's traditional kind of inbound yard management. But that same device also covers the part of the campus where you buffer work in progress. Those vehicles that are still in the production process, waiting for parts, waiting for repair, waiting for option upfit. And that single device, again, allows you to track all of those and make sure that that is optimized, that repair process is fully optimal, that the throughput is maximized, and avoid things like stuck inventory. It's not uncommon to have an unfinished vehicle sit out there for a lot longer than it's supposed to because it got parked in a corner and forgotten about. And that single device also covers the outbound logistics, the yard of finished goods which are lined up and batched and ready for loading, as I said, at the railhead or onto trucks or however they're transported, and to make sure again that that process is optimized, that everything is staged properly, that it's shipped on time. And so these three things that you never really think about together, which are really just the same problem in different parts of the process, now come under the purview of a single low-cost device that covers the entirety of the operation. And so it's clear then that the ROI becomes really quite exciting. And I don't want to spend a lot of time talking about the product itself. Please reach out to us for a demo if you're interested in finding out more. But the important thing here is that on the left, that's a typical car tag that you would hang on a rearview mirror. There are many other tag form factors depending on what you're tracking. That tag then connects to this single gateway device and then direct to cloud, where you can access the cloud portal either through any web browser or through your mobile device on iOS or Android. And connecting from tag direct to cloud is another very important part of how you deploy this very straightforwardly without a long, complicated process of integrating the solution with plant IT systems, which is often the longest pole in the tent in getting these things rolled out. Again, we've talked a little bit about this, but do reach out to us or come to the website for more information about the asset tracking technology. I've talked about outdoor. You can also learn some more about how we manage indoor tracking as well. I didn't talk about intralogistics today, but there's a whole other unconstrained process of getting parts distributed inside the plant, which we leverage similar technologies and techniques to make high value and low cost. And that integrates then with other plant systems like inventory management or resource planning or the MES quality system, whatever it needs to integrate with to create that data-rich environment. And then we talked about mobile apps. The thing about managing vast yards, it's an inherently mobile occupation. Out there, wandering across a huge campus, mobile access is critical and a core part of our system. And the software, again, I won't go into detail, but just to point out that we've talked about a lot of real-time connectivity. The day-to-day use of this is in exception management. I don't need to know the location of every trailer coming in, but I certainly need my phone to buzz and tell me when a trailer's gone to the wrong place, or its unloading is overrunning, or a dock door is sitting idle. So those real-time exceptions allow frontline supervisors to go and intervene in processes that need tweaking and pushing back into shape. The other part of the software is to monitor activity over time, which gives you a view on whether the process itself has inherent bottlenecks and inefficiencies that require you to actually alter process to keep things moving. The really important part here, and the part that I really want you to take away, is that this is very straightforward and quick to deploy. Going down the left-hand column here, from configuration of the application for the specific customer to connectivity on site to integration with the other plant systems, setting up the map and doing the training, can be done in days. 2 to 3 weeks is shown on here, and that's really the crux of what Cognosos and RTLS 2.0 is all about. As I said to you all along, taking the pioneer technologies which created the performance and the value, applying the new tools like the cloud and machine learning to reinvent RTLS in a way that makes it very low cost and quick and low disruption to roll out. I'm going to just end up with a couple of quick examples here. Here's one that was 0 to operational in less than 2 weeks. Less than 2 weeks from PO to creating value. This is Globus is a 3PL that manages the Hyundai Kia plants in the US, and this particular project is at the Kia plant in Georgia, West Point. And they were using what I would consider to be one of the kind of fairly ineffective legacy 1.0 solutions, which is a barcode scanner, where your fleet of vehicles out in the yard, someone walks the yard with a barcode scanner with a GPS in the barcode scanner, and as you scan the vehicles it registers what they are and where they are, but it doesn't really solve the problem. The problem of yard management is human error and human inefficiency, and all you've done there is move the human element to the manual barcode scanning. It doesn't really solve the problem. But this is a huge yard. This is a yard of 20,000 plus vehicles across a 600-acre site. And so they really needed a much more efficient solution. So they came to us and we installed there, as I said, in very quick time, less than a couple of weeks. And the first thing that they were able to do was note that there was a massive reduction in effort in terms of yard reconciliation. Previously, they'd have to do regular manual audits of the yard. Now, of course, that's completely automated, and that labor's reduced dramatically. Another example here is that this is on the finished vehicle side, but nevertheless, approximately 30 vehicles a day needed to return to the plant for some kind of recall action, and it would typically take them about 5 hours to execute that process. With full knowledge of where everything is all the time, that reduced to less than an hour using our technology. So huge labor savings and huge visibility gains here. Second one and the last one I want to show you is another major US OEM, and this is slightly different now. This is on a trailer yard. This is at a facility managing the distribution of aftermarket parts. It's 1,000 plus trailers serving a 2.5 million square foot warehouse, a giant operation. And once again, very quick to value here, very quick to set up. But then even in the first 3 months, this OEM had a suspicion that the 3PL managing the yard was making more trailer moves than necessary. And indeed, they were able to show that very obviously by monitoring where the trailers were and how they moved around on the lot. And with that insight and improving the process and proactively managing trailer movements, they were able to remove 20% of cost out of that yard management process, 20% of labor cost. And that's huge. 20% improvement in anything in manufacturing is really quite significant. So many more examples like that. Just wanted to touch on those two to give you an idea of how it works in the real world. And so I'll wrap up. The point about this, as I said, a new generation of real-time location system providing real-time asset visibility across the campus in a way that just works very quickly, a complete solution right from tag to cloud with very little impact or connection in with plant systems. Super easy to deploy, minimal infrastructure, and that gets to instant impact. And that's really the bottom line, is time to value. From decision to rollout to actually getting savings is just a few weeks and months with these Generation 2 systems. And so that's it. Thank you for your time. I really appreciate it. And here's a couple of ways to connect with us. And as I said, I'm happy to set up a demo if you'd like to know more about the product itself. And do seek out the white paper if you're interested in learning more about what differentiates the new generation of location solutions. Thanks for listening.